Imagine an entire continent buried 2 miles under ice. What could be living there? Beneath the endless white expanse lies a secret world, untouched for millennia and cloaked by 2 miles of relentless ice. Scientists call this hidden realm a continent, a massive landmass that has lain dormant beneath the frozen blanket. Imagine entire mountain ranges, valleys, and lakes concealed beneath that thick, invisible armor of frozen water. But how can we know what lies there when no human eye has ever pierced that barrier? Our only clues come from the faint whispers of radar, gravity maps, and seismic tremors echoing through the ice. These instruments sketch an invisible outline, hinting at a massive landmass waiting to be uncovered. Thus begins our quest, to reveal what extraordinary ecosystems and ancient geology might thrive beneath Antarctica's frozen veil. Beneath the white expanse, wind and snowfall compress each layer, turning snow into dense crystal over millennia. Year after year, gravity piles more than 2 kilometers of ice, each meter adding pressure that seals the world below like a freezer. This immense weight forces air bubbles to vanish, erasing any direct line of sight and turning the surface into an impenetrable shield. Scientists drill through this barrier with specialized hot water drills, but even a narrow borehole reveals only a fraction of what lies hidden. Because light cannot travel beyond the opaque depths, satellite images show only surface patterns, leaving the interior cloaked in darkness. The ice acts like a time capsule, preserving ancient atmospheres and trapped water while simultaneously isolating any life beneath from observation. Thus, every discovery demands ingenuity, for the frozen wall hides secrets that could reshape our understanding of Earth's history. Beneath the endless white, a continent of ancient stone stretches out, its roots forged over 1 billion years ago, and its mineral composition tells a story of early Earth. This primordial crust forms the East Antarctic Craton, a massive block of some of Earth's oldest lithosphere, shielded by kilometers of ice and forming the stable heart of this frozen realm. Geologists compare it to the cores of other continents, like the Canadian Shield, its rocks bearing scars of ancient collisions, volcanic fires, and prolonged erosion that shaped early supercontinents. Seismic waves bouncing through the ice reveal a uniform, thick mantle beneath, suggesting a vast, stable platform untouched since the supercontinent Gondwana fractured and drifted apart. Magnetic surveys map subtle anomalies that outline the hidden landmass, hinting at mountain ranges and deep basins buried in frozen silence. These clues point to a continent rivaling Africa in size, waiting to emerge as climate warms and technology pierces the veil. As this hidden continent surfaces, it promises a new chapter in Earth's deep history and a fresh frontier for scientific discovery. Scientists launched airborne radio echo surveys, sending low-frequency pulses across the polar plateau to map subsurface structures. When these waves reflected off unseen structures, bright echoes painted a hidden topography on their screens, revealing ancient geological clues. The patterns revealed linear ridges and sharp discontinuities, unlike any surface feature known beneath the ice, suggesting massive buried formations. Further ground-based radar traverses traced towering silhouettes, suggesting peaks rising thousands of meters above the bedrock that could reshape continental models. These massive anomalies sparked intense debate, as researchers compared them to ancient mountain ranges erased by glaciation, raising questions about Earth's hidden history. By combining multiple frequencies, teams filtered noise and highlighted the true geometry of the buried terrain, enhancing confidence in the emerging map. The refined maps showed a chain of colossal formations stretching across East Antarctica, hinting at a lost continent awaiting further scientific confirmation. Scientists realized this discovery rewrote expectations of Antarctic geology, opening doors to unprecedented exploration for future generations. Beneath the ice, researchers identified a massive uplift spanning over 2,000 kilometers, rivaling entire continents and promising new insight for future study, and altering our perception of Earth's polar dynamics. This rise towers up to 2 kilometers above surrounding bedrock, forming hidden peaks that reveal ancient layers and beckon deeper exploration for future study across the continent's interior. Satellite gravimetric maps confirm the anomaly's continent-scale size beneath the frozen veil, reshaping Antarctic geology for future study and guiding upcoming expeditions. Geologists see an ancient mountain range, its roots deep in Earth's mantle, hinting at forces that shaped this hidden world for future study. The uplift challenges old models of a flat plateau, forcing scientists to redraw maps and hypotheses for future study. Its discovery points to tectonic uplift that reshape the continent, opening new research avenues for future study. Future drilling will sample these heights, unlocking clues about ancient climates and crustal evolution for future study. Beneath West Antarctica's icy veneer, airborne radar has pierced the frozen crust, revealing massive basins that plunge more than 3 kilometers below sea level. These depressions stretch for hundreds of kilometers, forming trench-like corridors that run parallel to the coast and cut deep into the continent's interior. Scientists compare them to oceanic trenches, noting their steep walls and flat floors, which suggest ancient tectonic rifting long erased from surface maps. The radar echoes show layered ice overlying a smooth, low-gravity anomaly, confirming that the basins are filled with water-saturated sediments rather than solid rock. Such hidden topography could rewrite our understanding of Antarctica's shape, showing that large swaths lie far beneath sea level, reshaping mass balance calculations. Future surveys will integrate these basin maps with satellite gravimetry, refining models of ice flow and predicting how meltwater may channel toward the ocean. Building on those basin maps, researchers uncovered vast, ancient meltwater channels etched beneath the ice, their sinuous paths revealed by radar reflections. These corridors suggest a hidden hydrological system that persisted through multiple glacial cycles. These hidden valleys stretch for tens of kilometers, their smooth floors hinting at water flowing long ago when temperatures briefly rose. Their smoothness indicates prolonged flow that eroded the rock over centuries. Radar slices show steep sidewalls flanking the channels, suggesting they cut through bedrock rather than soft sediment. Scientists date the carving events to glacial interludes during the last million years, periods when surface melt pooled and surged beneath the frozen lid. These subterranean rivers likely acted as conduits, channeling meltwater toward deeper basins and eventually to the ocean, reshaping ice dynamics. The discovery adds a new layer of mystery, implying that hidden waterways have been sculpting Antarctica's interior far longer than previously imagined. Deep beneath the frozen crust, a colossal lake lies 4 kilometers down, cradled by rock, a mirror of Earth's primordial seas. Named Lake Vostok, its waters have been sealed from sunlight and atmosphere for roughly 15 million years, trapped beneath kilometers of clear ice. Pressure from the overlying ice keeps the lake in a permanent liquid state despite the frigid exterior. This hidden pressure also raises the lake's temperature enough to stay fluid. Scientists infer that this isolation creates a unique chemical environment rich in dissolved gases and minerals. The lake's depth exceeds 2 kilometers, making it one of the deepest subglacial basins on Earth. Remote drilling missions have pierced the ice, retrieving pristine water samples without contaminating this hidden world. Each core slice is sealed in sterile containers, preserving the lake's chemistry. Analyses reveal microbial DNA signatures, sparking speculation about life thriving in perpetual darkness. Could these organisms resemble ancient ancestors, or even inform the search for extraterrestrial habitats? Their metabolic pathways might hint at life's resilience on moons like Europa. Without sunlight or atmospheric exchange for millennia, Lake Vostok's waters have become a time capsule, sealing biochemical signatures untouched elsewhere on Earth and preserved for future study. Microbial life thrives in isolation, metabolizing chemolitho-autotrophic pathways that require no sunlight, relying solely on the chemical energy locked in ancient rocks. These biosignatures echo what scientists expect on icy moons, where oceans sit beneath kilometers of ice and are cut off from the surface. Because no external microbes can enter, genetic drift has produced lineages found nowhere else on the planet. Such isolation makes Vostok a natural laboratory for testing life's limits and refining our search algorithms for extraterrestrial biosignatures and calibrate detection thresholds for methane and organic compounds. In essence, Vostok's sealed world offers a glimpse into how life could endure beneath the ice shells of distant worlds, waiting for us to listen. In 2021, the Russian team finally broke through Vostok's pristine barrier. The first water sample surged up the borehole, a clear plume rising into the sterile lab air. Scientists immediately detected living microbes, tiny archaea and bacteria thriving in darkness. Genetic analysis revealed unknown lineages, some resembling deep-sea vent organisms despite the lake's isolation. Chemical tests uncovered elevated concentrations of hydrogen and methane, fuels that could sustain chemosynthetic life. Even trace amounts of ammonia hinted at nitrogen cycling, previously unseen in polar subglacial waters. These findings shocked the community because prior models predicted a barren, chemically dead lake. Now researchers contemplate how such resilient ecosystems survived for millions of years, under crushing ice, indicating a hidden energy source, perhaps from radiolysis, of water driven by natural radioactivity. These astonishing results compel scientists to redesign experiments, seeking to culture the microbes and decode their metabolic pathways. Beyond the frozen lake, researchers draw a direct parallel between Vostok's subglacial ocean and Europa's concealed seas beneath its icy crust. Both environments endure relentless cold, crushing pressure, and eternal darkness, sealed under kilometers of solid ice and zero sunlight. In this isolation, natural radioactivity continuously splits water molecules, generating reactive hydrogen and oxidants that fuel chemistry. These radiolytic products become the sole energy source for chemosynthetic microbes thriving without any sunlight in complete isolation. On Europa, scientists hypothesize that comparable processes could sustain life within briny pockets hidden beneath its frozen shell. Thus, Vostok acts as a terrestrial analog, allowing experimental validation of potential alien metabolic pathways. Understanding these earthbound extremes sharpens our strategies for detecting biosignatures on distant icy worlds, bringing us closer to answering humanity's greatest question. Future missions will probe similar subice oceans, using lessons learned from Vostok to recognize the faint signs of life beyond Earth. High-resolution sonar sweeps stitch together a digital landscape, exposing jagged ridges that pierce the ice sheet like frozen spines. These data streams converge, painting an unprecedented picture of Antarctica's concealed spine. These virtual contours reveal mountain peaks soaring over 4 kilometers above sea level, dwarfing even the tallest summits of the Himalayas. Scientists overlay gravity anomalies onto the model, confirming that dense rock cores underlie the ice, just as they do in continental ranges. The latest rendering uses AI-enhanced interpolation, filling gaps between sparse drill data to create a seamless view of the hidden topography. When rotated in virtual reality, the mountains appear to rise abruptly from the bedrock, their sharp ridgelines casting long shadows across the frozen plain. Mapping these hidden giants reshapes our understanding of the continent's geology and hints at vast mineral reservoirs locked beneath miles of ice. These subglacial mountain ranges act like hidden buttresses, redirecting the flow of Antarctic ice toward the coast and stabilizing downstream glaciers. Where valleys deepen, ice thins and accelerates, creating fast-moving corridors that feed into major outlet glaciers, dramatically reshaping mass balance. Scientists compare satellite gravimetry with detailed bedrock topography to quantify precisely how these hidden features modulate basal friction and influence ice sheet dynamics. Variations in ice velocity leave distinct imprints in the stratified ice layers, preserving a dynamic record of past flow patterns that can be read like ancient fingerprints. By decoding those layered signatures, researchers can correct climate models that previously assumed uniform ice behavior, improving predictions of future sea level rise. Accurate reconstructions reveal periods when hidden basins trapped meltwater, altering sea level estimates for ancient warm intervals and highlighting feedback loops in Earth's climate system. Together, these insights elevate Antarctica's concealed landscape from a curiosity to a cornerstone of global climate history, underscoring its critical role in planetary change. Next year, a swarm of autonomous rovers will drill through kilometers of ice, gathering pristine core samples, targeting regions where ancient ice meets bedrock, unlocking clues about past atmospheric composition. Equipped with low-temperature drills and onboard labs, they will analyze gases, microbes, and mineral fingerprints in real time. Above the surface, high-altitude drones will map fissures using laser altimetry, revealing hidden pathways for future access. Simultaneously, satellite-borne interferometric radars will pulse through the ice sheet, producing three-dimensional velocity models of subglacial flow. These models will guide the placement of next-generation drilling rigs capable of reaching the deepest basins beneath West Antarctica. International teams plan to deploy quantum gravimeters on ice flows, measuring minute variations in Earth's field to map hidden mountain ranges. Together, these cutting-edge tools promise a new era of discovery, turning Antarctica's secret world into a laboratory for planetary science. Beneath the endless white, a lost continent rises, its jagged peaks piercing the ancient ice. Their silhouettes carve shadows across the frozen horizon, hinting at continents lost to time. These mountains, older than continents above, tell stories of Earth's deep past frozen in stone. Geologists decode their strata, uncovering epochs of tectonic drama preserved beneath the snow. Meanwhile, beneath a thick sheet of glacial water, Lake Vostok swirls with life unseen. Temperature gradients create swirling currents that sustain these fragile communities. Microbial colonies thrive in darkness, feeding on chemical energy, forming ecosystems unlike any on the surface. Their adaptation mirrors alien worlds, offering a living laboratory for astrobiology within Earth's own poles. The discovery reshapes our map, revealing that Antarctica guards both towering ancient ranges and hidden biospheres. As we lift the veil, the planet's final frontiers emerge, urging us to explore further. The hidden continent is a massive, ancient mountain range, and Lake Vostok hosts a unique, isolated ecosystem that may resemble alien life. Subscribe for more hidden Earth mysteries